Hello students and welcome to the lecture. So students, as you can see here that basically in this lecture we are going to start our discussion over the surface tension, okay, and that is going to be our part 1. Okay, in this lecture basically we will discuss about the intermolecular forces and types of intermolecular forces. These two are going to be a point of discussion for us in this particular lecture. But before starting this lecture, there is a small disclaimer over here that we are required to understand before we proceed further. The disclaimer is like the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin with the topic first, that is going to be our intermolecular forces. So, what do you mean by this? So, basically, to understand the phenomenon of surface tension, it is necessary to have some idea about the intermolecular forces, okay, which operate to keep the liquid molecules together. I hope now you have understood why the surface tension having this particular topic to be discussed. Like without having a knowledge of intermolecular forces and their action, you would not be able to talk about the phenomenon of surface tension. Because surface tension is directly, or you can say is actually relevant to the intermolecular forces, and this intermolecular forces operates to keep the liquid molecules together. The forces between the molecules or the substances are called the intermolecular forces. Intermolecular forces are effective only over short distances, so that's why these are also known as the short range forces. Moreover, these forces do not obey the inverse and square law. So now you can say there are the several things that we are required to understand. First, that what are the intermolecular forces? So basically, there are the atoms. This is the smallest unit of any matter. Okay, and when the atoms form a group, they known as the molecules. So intermolecular forces is actually a force of attraction or force of binding acting between these different molecules through which basically the molecules are getting attached to each other. Okay, so that's why we could say intermolecular forces are the forces between the molecules of the substances through which the substances having their particular shape, size, okay, and they bind it together. Got it? But remember, intermolecular forces are not the long distance forces or not a long range force. They having short distances, and that's why they are called as the short range forces because they're acting between the molecules only, not beyond the molecules, not to any other area, but only between the molecules. That's why these are known as the short distances or short range forces. Secondly, you can say they are not obey the inverse and square law. So what do you mean by this? So basically, inverse and square law is the law of physics which states that any physical quantity having some intensity, and the intensity of physical quantity, if it's depend upon the source and the distance between it, then we could say it is actually following the inverse and square law. If it is not dependent between this, then it is not following the inverse and square law. Okay, so remember, to measure the intensity of any physical quantity, if the intensity is decreasing while increasing the distance, and if the intensity is increasing while decreasing the distance, so in that scenario, that physical quantity is following the inverse and square law. After finishing the intermolecular forces introduction, let's have a look over the types of intermolecular forces. So the Intermolecular forces are electrical origin, and these forces also known as van der Waals forces. So if it is asked in the examination, like what is the another name of intermolecular forces, remember the another name of intermolecular forces is van der Waals forces. These are two types of intermolecular forces. First is forces of adhesion or adhesive force. Second, force of cohesion or cohesive force. So this is the two types of intermolecular forces that exist. Forces of adhesion or adhesive force, force of cohesion or cohesive force. Got it? First, force of adhesion or adhesive force. So actually, it is the force of attraction acting between the molecules of different substances. Now you can say this is not the case of only one substance, but the different substances are included here. Why? Because when the force of attraction is not between the molecules of the same substance, but in between the molecules of different substances, then the force of adhesion or adhesive force is actually working in this scenario. For example, the water wets the surface of a glass container. Why? Because the molecules of glass container got into the contact of the molecules of water, and that's why the force of attraction start acting between these molecules, and this happens. This is due to the force of adhesion between the water and the glass molecules that I have told you. Why? Because the water is different substance and glass is different substance. Okay, but their molecules having a force of attraction between. Now force of adhesion is different for different substances. Force of adhesion is different, like you can say some of the substances having a high force of adhesion, while the same substance is not having that kind of force of adhesion with any other substance. Okay, so when the substance got changed, actually the force of adhesion also gets changed. Example, gum has a greater adhesive force for a solid surface than water. So here you can see, if you put gum over a solid surface, you will find out that the glue will be stick there. Similarly, if you try to push water on the solid surface, what will happen? The water will slip it down. Why? Because the force of adhesion or the adhesive force between the glue and that particular solid substance is higher in comparison with the water and that particular solid substance. Then, force of cohesion or cohesive force. This is the second type of intermolecular forces. So force of cohesion or cohesive force is actually the force of attraction happening between the molecules of the same substance. Now we could say substances are not different as in the case of adhesion or adhesive force, but in this case the substances are similar, cohesion and cohesive force. Okay, so the force of attraction between the molecules of the same substance is called the force of cohesion or cohesive force. The force of cohesion is maximum in case of solids, lesser in liquid, and least in gases. That's why the molecules in solid stick together with more force, so it is hard to separate them. That's why it's hard to mold the shape of solid, break the solid. Okay, it is lesser in liquid in comparison with solid. So that's why we could easily change the shape of solid, we could easily pour it out, pour into it, and all. And least in gases. Okay, like in the case of gas, it is totally least. All right, the solids have definite shape and size due to the strong forces of cohesion between their molecules. Mercury does not wet the surface of a glass container because the force of cohesion between the molecules of mercury is stronger than the force of adhesion between the molecules of mercury and the glass. So that's why the molecules of mercury got stick together instead of getting stick to the walls of glass container. So that's why whenever you pour the liquid mercury into glass container, you will find out that the glass container walls will be dried. The mercury is not, you could say, wetting the walls. The cohesive and adhesive force varies inversely as the seventh power of distance between the molecules. Therefore, the cohesive or adhesive force increases rapidly with decrease in distance between the molecules. So we could say if the distance between the molecules is higher, automatically the cohesive or adhesive forces will be lower. If the distance between the molecules will be lower, automatically the cohesive or adhesive forces will be higher. Okay, so it is totally depend upon the distance between the molecules. The intermolecular force binding energy of liquid is the minimum energy required to separate two molecules of a liquid from each other's influence. Intermolecular binding energy, remember it. Intermolecular binding energy. That is actually the energy required to separate the two molecules of a liquid from each other's attraction. Okay, and it is also the minimum energy required to that. The intermolecular binding energy is less for water and more for mercury because the mercury having the high cohesive force. That's why the molecules of mercury are getting attached to each other with a intensive force, and that's why it is not wetting the walls of glass container. Now, important terms that are related to the study of surface tension of liquid. First, molecular range. It is the maximum distance up to which a molecule could exert some measurable attraction on other molecules. It is the maximum distance. So we could say like if there is a you can say picture. Here it is one molecule and suppose there is a another molecules. So now you can say you are seeing that there is a particular region, this radius of that particular circle if we draw it. Okay, so up to this distance only this molecule could have a attraction on the other molecules that is measurable or that could be measured. If the molecule is presented here not in that range, then what will happen? The molecular attraction will not be that much of intense if it was here. All right, that is the molecular range, maximum distance up to which a molecule could exert some measurable attraction on other molecules. It is different for different substances. The order of molecular range is 10 power minus 9 m in solids and liquid. And this is the one of the statement that you are required to understand. It is different for different substances. Some distances having a long molecular attraction, some distances having a medium, or some distances having a low range molecular attraction. Thereafter, the sphere of influence. Actually, it is an imaginary sphere drawn with a molecule as center and the molecular range as radius. Again, I'm saying it is a imaginary sphere drawn with a molecule as center and a molecular range as radius.